Hi everybody, Mr. Garrett here, and I wanted to talk briefly to you about restricting the domain of functions so that the inverse of a function is also a function. And so we're going to start here with our favorite quadratic function, f of x equals x squared. And if I draw this graph, we got our favorite points 0, 0, 1, 1, 2, 4, and 3, 9. We also have negative 1, 1, negative 2, 4, and negative 3, 9. And so when I connect these points, draw my line in here, I get a parabola. And so there's f of x, which is x squared. Now, when I go to draw the inverse, I switch my x's and y's. So 0, 0 stays 0, 0, and 1, 1 stays 1, 1. But 2, 4 now becomes 4, 2, and 3, 9 now becomes, let's see, 4, 6, 8, 9, 3. We also have negative 1, 1 becomes 1, negative 1, and negative 2, 4 becomes 4, negative 2, and negative 3, 9 becomes 9, negative 3. And so my inverse function looks like this. Or my inverse, I should say, of f of x becomes this. Now, I know it's a little sloppy, but here's f inverse of x. Now, the only problem with this graph is if I were to go ahead and do the vertical line test on the inverse function, I can see that this vertical line hits the green graph, f inverse, twice. And therefore, f inverse is not a function. And so one of the things that we can do is we can restrict the domain of f of x so that f inverse is a function. Because in Algebra 2, we don't like working with non-functions, and so we try and work with functions only. So let's go ahead and take a look. And here you can see I've added this constraint that says x is greater than or equal to 0. Which means that when I go to graph it, I'm only going to graph the right side of this graph. X is 0, x is 1, x is 2, x is 3. And you can see now, here's f of x, and it's just a right side of a parabola. Now when I do the inverse of 0, 0 is 0, 0. The inverse of 1, 1 is 1, 1. The inverse of 2, 4 is 4, 2. And the inverse of 3, 9 is 9, 3. And you can see now that I have this as f inverse of x. And the good thing about that is when I draw the vertical line test now, I can draw a vertical line here, 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 here. It doesn't matter because each time it only hits the graph once, and I can say f inverse of x is a function, and then we can work with it. Now, when we go to try and find this using changes in x and y, I'm going to make this y equals x squared. And then I switch x and y to give it x equals y squared. And then to undo the square, I square root, and I get square root of x equals y. And I can say that f inverse of x is the square root of x. Now I don't have to put this stipulation here because this is only dealing with positive numbers or non-negative numbers, okay? And so if I graph this, this here is my actual graph. Back here, if I were to do this, when I found the inverse, I would have to say f inverse equals plus or minus the square root of x, which would give me the positive square root of x and the negative square root of x graph. And that's, again, not a function. So when we look at something like this, we have negative x squared plus 3. Here we have the domain being restricted so that just the positive numbers are there. This means that the graph is upside down. This means it's moved up 3. And so the vertex here is at 0, 3. If I plug in 1, I get 2 because 1 squared is 1. Take the negative of that is negative 1 plus 3 is 2. If I plug in 2, that would be 4, negative 4. so that's -1. And then if I plugged in 3, I would get 6 as well, which is down here off the graph. And so when I graph it, this is what I get. Now, how can I tell if the inverse will be a function or not? Well, we can do the horizontal line test. And so the horizontal line test tells us that inverse of a function is also a function if and only if no horizontal line intersects the graph more than. So we have the vertical line test, and the vertical line test will say, okay, well, this right here is a function. This right here is not a function because, again, that vertical line would cut through it twice, there and there. And then if I have one more, something like this, it's not a function because the vertical line cuts through twice. Now, the horizontal line test doesn't tell us if it's a function or not. It tells us if its inverse will be a function. So when I look at something like x cubed, the horizontal line test passes through, only touches one time each, right there, and right there. And so its inverse is a function. Whereas if I look at something like x squared, the parabola, when I see this, it hits once, twice, and therefore the inverse is not a function. So if I look at the one more and I said, okay, well, what about a polynomial that looks like this? Will that have an inverse that's a function? Well, if I take and draw a horizontal line there, it hits once, twice, 3 times, and therefore its inverse is not a function. And that's the horizontal line test and how we restrict the domain so that we can have inverses of functions still be functions. So I hope that helps, and thanks a lot.